Okay, to solve question 9, the directions say to identify any figures that can be proved to be congruent. And what I've done is copied over this diagram and color-coded the markings that were given to us. My one concern is from the answer key, and I don't have the worksheet in front of me, but I was able to get online and see a version, and I'm not sure if the online version left out these pieces or if all versions were. These pieces right here are critical according to the answer key. If we don't have these pieces, by definition of congruency, we can't prove these triangles congruent. Now, if we have them, we can, and that's what I'm going to do. I'm going to walk through this process as the answer key states. Now, tomorrow we are going to learn some shortcuts that would allow us to figure this out. But again, from just the definition of congruency that we know so far, these pieces are critical. If these markings aren't here, disregard this proof and just say there are no congruent figures. This is not possible. Now, if you notice how I color-coded these diagrams, really the two triangles that we are concerned with. So let me. That's a W. The two triangles that we're concerned with are this triangle X, Z, W, and this triangle Y, U, W. Now from the markings, we see that this angle W, which here would be angle Y, W, U, is congruent to this angle W, which would be X, W, Z. Okay. In the diagram, we also see that side WU is congruent to side XW. We also see that side WZ is congruent to side WY. We also see here that angle Y, which would be WYZ or WYU, that angle is congruent to angle Z or XZW or WZX. So right now, by the definition of congruency, remember, we need to prove that all corresponding angles and all corresponding sides are congruent. And right now, we have 4 of the 6 that we need. By the third angle theorem, and this was in the answer key, by the third angle theorem, we can prove that angle X is congruent to angle U. Okay? Statement, angle X is congruent to angle U. Reason, third angle theorem. So now we have 5 of the 6. The last part that we have to prove congruent is that this side XZ is congruent to this side YW. Now, XZ, okay, take a look at this diagram. It should have a point Y here. Okay? Now, this little part here, XY, is supposed to be congruent here. This part, U, ZY, is supposed to be congruent to this part here. Now, by segment addition, XZ is equal to XY plus YZ. And over here, UY is equal to UZ plus YZ. Now again, these parts are the same. These parts right here, if we know that these are congruent, we can prove that XZ is equal in length or congruent to line segment UY. That part, if it has been given right here, XY equal to UZ, if this part was given, then by segment addition we can state these two, that xz is equal to this sum and uy is equal to this sum. And then by substitution, we can say that xz is equal to uz plus yz, proving that these two are equal to the same sum of segments, which by substitution of the transitive property, we could then say that uy is congruent to xz, and that's what we're looking for. Okay, the uy is congruent to xz. So again, this critical part allows us to make that sixth and final congruent statement. So by the definition of congruency, we can state that these triangles are in fact congruent. Let me use 4 marks here, not to be confused with the 3. So if that's there, then we're able to make all 6 of our necessary congruent statements to prove these triangles are congruent. When we name these triangles, again, the order does matter. First triangle can start out in any order. I'm just going to go from angle with 1 congruency arc to 2 to 3. So I'm going to say triangle WZX is congruent to triangle 1 to 2 to 3 WYU. Any variation of this would be correct as long as whatever you change here, you've changed correspondingly, I guess I would say, to what's over here. So again, that's how I would solve question number 9. Again, if this piece of information is there. Okay. If it's not, okay, it's not possible, and we can talk more about that in class tomorrow.